How to balance a redox equation in acidic and alkaline medium respectively. First of all, you have to be clear whether a reaction is a redox or not. And if after you memorize those common reducing agent and oxidizing agent, I think you can immediately know the answer. So for example, in this case, for permanganate ion, we react with Fe2 plus, and then for MnO4 is obviously an oxidizing agent. If you are not sure, then just write down its product. It should be Mn2 plus in acidic medium. And if you check the oxidation number for Mn, it decreases from +7 to +2. So here is a reduction of oxidation number. It should undergo reduction, and it should be an oxidizing agent. And for the balancing of this kind of redox equation, we have to use the method of half equation. It means that for oxidizing agent, we balance the equation once, and then for the reducing agent, we balance the half equation, and then we add them up. So for this case, we have to balance the atom apart from oxygen and hydrogen, that is Mn, and in this case, for both sides, it consists of one Mn atom, so that it is said to be balanced. And then we balance the number of oxygen by adding H2O. And here there are 4 oxygen atoms, so that we add back 4 water molecules to balance the number of oxygen. And then we balance the number of hydrogen by adding hydrogen ion, and 2 times 4 equal to 8, so that we add 8H plus in this case. And finally, we check the overall charge. On the product side now, there is an overall +2 charge. +2 plus 0 equal to +2. And then on the reactant side, it should be +8 minus 1 equal to +7. So we have to add back 5 negative electrons on the reactant side to balance the charge. And then -5 plus 7 equal to +2, and it actually equal to the charge on the product side. And you can do the double check, is because for this 5 electron, it actually means that it undergo 5 times of reduction. And if we check the oxidation number, MnO4, the oxidation number for Mn is +7, and then it decreases to +2. It means that during the process for permanganate to become manganese 2 ion, it undergo 5 times of reduction, and of course it absorbs 5 electrons. So here is the balance equation for the oxidizing agent. And then for the reducing agent, Fe2 plus, it will become Fe3 plus and 1 electron. And here is the equation for the half equation for the reducing agent. And what we have to do is to find out the LCM of the number of electrons. So we have to multiply the equation below by 5, and the overall result is that HH plus, because we have to multiply it by 1, so that just direct copy it is enough. And then for Fe2 plus, we undergo the second equation by 5 times. So we have 5 Fe2 plus as the reactant, and then it will become 5 Fe3 plus and Mn2 plus and 4 H2O, and that's it, the balance equation. And each time when you're balancing a redox equation, you have to do it by this, we call it half equation method. I want to show you one more example, maybe about dichromate. What is dichromate? Remember, chrome means Cr, di means that we have 2, and dichromate, and with ATE means that it consists of some oxygen. And in this case, it's Cl2O7 2 minus. And what's the product? If you haven't remembered it yet, just memorize it. Cl3 plus after the process. And in this case, I want the dichromate in acidic environment to react with Okay, sulfite ion. And sulfite we end with ITE with one oxygen less than sulfate, SO4 2 minus. So this formula is SO3 2 minus. However, we have to balance the equation separately for OA and RA. Oh, for dichromate first we have to balance the atom apart from oxygen and hydrogen. In this case, only one, that is Cr atom. On the reactant side, there are two chromium atoms. So on the product side, we have two chromium 3 ions from. In the second step, balance oxygen by adding H2O, and then balance hydrogen. Okay, there is totally 7 times 2, that is 14 hydrogen atom, and we add back 14 hydrogen ion to balance it, and then we check the charge for the product side. Plus 6 plus 0 is totally plus 6 for the overall charge on the product side. And then for the reactant side, in this case, plus 14 minus 2, okay, only plus 12. So in order to balance the charge, we have to add back totally 6 electrons, 6 negative electrons on the reactant side. And if you are checking the oxidation number for double confirm, for Cr2072 minus, the total oxidation number, it should be plus 6 for chromium atom, and then it will reduce to plus 3. It means that it decreases from plus 6 to plus 3, a decrease of 3. However, there are 2 chromium atoms, so overall it will do 6 times of reduction. So that of course release 6 electrons on the reactant side. So then for the reducing agent, SO3 2 minus, SO4 2 minus, the number of S is balanced already, and then balance O by adding H2O, balance hydrogen by adding H plus, and finally balance the charge. And again, double confirm it by the oxidation number change. For S is plus 4, and it will become plus 6, and increase by 2 in oxidation number for sulfur. It means that it undergoes 2 times of oxidation, and totally it loses 2 electrons. And up to this stage, we have to add them up and multiply the equation below by 3 to provide totally 6 electrons to be absorbed by this dichromate ion. So finally we can get direct copy. And then for this water molecule, we totally use the 3 water molecule. However, finally we delete some of the water molecule. It's an immediate result before you delete anything. And you can see that for this hydrogen ion, you can delete 6 of them. And then for water molecule, you can delete 3 of them. So the overall result is that 1 dichromate we add with H plus, and then 3 sulfite ion. And then it will become 2 chromium 3 ion, 4 H2O, and then 3 sulfate. And that's it for the balancing for the reaction between dichromate and sulfite ion under acidic medium. And finally, how about under alkaline medium? Okay, we do the balancing equation, and again I use maybe permanganate. Yeah. And for permanganate is a little bit special. It's because it will form another product, MnO2, in the process, but not MnO2 plus. In the balancing of this equation, we have 2 methods. The first method is that we can follow the one by using acidic medium, by just adding H2O to balance the number of oxygen, and then we add back hydrogen ion to balance the number of hydrogen, and then finally we deal with the charge difference by adding electron. And you can double check it. Originally it's +7 for Mn oxidation number, and then it will decrease by 3, so that it will gain 3 electrons to form MnO2. And up to this stage, all of the species are balanced already. However, under alkaline medium, there should not be any H+. We want it to become hydroxide ion. So we add hydroxide ion on the both sides, and then just treat them as undergoing neutralization. This part is actually equal to 4 H2O, and they will delete with the 2 H2O on the product side. So here is the overall result. It is based on the method for balancing this equation under acidic medium. And the other way is that we balance the hydrogen, oxygen by using hydroxide ion directly. And again, we write down the product and reactant in terms of their formula. And then the second step is check the oxidation number. You can see that there is a +7 decrease to +4 oxidation state change. So we add back 3 electrons to balance the charge. To balance the electron flow. And then we balance the charge by adding hydroxide ion. There will be totally 3 negative charge minus 1 negative charge, and there are totally 4 negative charge. So we add 4 hydroxide ion to balance the charge. And finally, we balance oxygen and hydrogen together by adding H2O. There will be 2 oxygen less. There will be 2 oxygen missing on the reactant side, and then 4 hydrogen missing on the reactant side. So after you check the combination, we're missing 4 H and then 2 oxygen. You can see that we will totally need 2 H2O molecule to balance the equation. So here is the final result if you are using just hydroxide ion to balance the equation.